Hello. So in this episode, we're going to really focus on building our skills in Excel through data cleansing, analyzing and summarizing data through pivot tables, and adding functions and different formulas. And then we're going to combine all of these skills that we built up and challenge ChatGPT. Yes, we're going to challenge AI. So make sure you stay to the end as we develop your skills in Excel.
Over 85% of NHS staff still use Excel, some to varying degrees. So, just a reminder, despite all of the incredible advances that we've seen in technology in different platforms and AI, Excel is still such a relevant platform for those who are analysts as well as other professionals. Even some of the most talented analysts and scientists I know will still quickly do something in Excel if they need to do it. So, having the base foundations of utilizing Excel is so fundamentally important.
All right, so now we're going to be focused on data cleaning. So before I manipulate and utilize different techniques, the first thing I always try to ask myself and tell others who are willing to listen to me is what are you actually trying to analyze? What's the actual real objective? Because if you understand at this stage, it really helps you with your analysis. So we get given a little bit of a clue because the tab itself is called hospital admissions. But if it was called hospital activity, then in the healthcare setting, you might be thinking of admissions, you might be thinking episodes of care, you might be thinking of spells, you might be thinking a number of patients. All of that type of analysis aggregates differently. So it's really important to just understand that beforehand. That also gives you the opportunity to remove any columns of information that's not required. The more streamlined your data set is, the better usually your visualizations work and the more effective that they can be in the analysis. After I've understood that, then I'll just try to verify that I understand what each of the field actually means. So for instance, if I was didn't extract the data myself, the first question I might have here is if this region is the patient region or is it the hospital region? LOS, it tends to stand for length of stay. So I would just verify that that's what we're actually looking at here. These date values are date values that Excel actually does recognize, but they're not in the format that was naturally useful. We're probably looking at the primary diagnosis here, the gender, male or female, which is like a Boolean figure, the patient age, hospital, and admissions. So the second thing I'll go on to do is just make sure that each of these fields are in the right data type or format. So I'll highlight the whole field and I'll go into here and you can see some of the popular formats. And we're going to be over prescriptive and use text for the region because it's a text value. But a lot of times when you open up Excel, it tries to put in that general field, which allows it to kind of aggregate and do things well, but it can make a lot of mistakes. So putting into the right format and type really helps you and helps Excel to do its thing appropriately. It's also a good concept even when you use other platforms as well. It's really, really important. So we're going to put that as a text. Length of stay, we're going to put as a number. We're going to use the decreased values. And we're going to be super clear and name it length of stay. And we're going to put in brackets days. Obviously, not something I verified, but generally, when admission data is recorded, it's length of stay days. We actually have the opportunity to verify that's correct because we got an admission and discharge date. So the discharge takeaway admission should actually equal the length of stay. The admission and discharge date, the format type that we're gonna use is a short date, which is common in the UK. Just doing that double check, 13 take away 11 equals 2, so that's all good. The diagnosis, we're gonna put into text. The gender, we're gonna put it into text as well, although it's kind of like a Boolean, male or female, but we'll put that into text. The patient age, we'll put as the number. Decrease those decimals, because irrespective of what young ones might tell you, you can't be zero point 0.5 in an age usually when you're doing patient age analysis. The hospital we'll put as a text, and the admission ID is actually a typical example of general because it's both text and numerical value. So we'll leave that as it is for now. The second thing I try to do is I try to identify if there's any blanks in the data. So if there's any rows. So there's different methodologies with dealing with missing data. Sometimes the simplest way is just not to include it in your data set and just highlight when you're doing your analysis the exclusions that you've made. An easy way to do that when you're dealing with smaller data set is just use the filter function and just have a quick look into the filters to see if there's anything that you're not expecting or you don't want. For instance, in my length of stay, we have some blanks there, and I don't really want those blanks. So this would be something that we would address right away. Now, there's two ways to address it. Obviously, you can just enter in the value, but you can also use the find and replace with Control F or Control H and replace any of those blank values. Now, when you're doing a replace, make sure that if you're just trying to replace one specific thing, that you put match entire cell contents and you highlight the error that you want the replacing to actually occur. Because if I were to make this a one, for instance, it would replace any value that has one. So even the length of stay of 11 would be replaced with something else. Actually, the one should have been up there, and I should have put something down here just to make the example even more clear. So we're going to put that as a length of stay of 0 for now. No need to exclude it because it has all of its relevant information. And then we look at the rest. So our discharge date goes up to June. It starts towards in April. We got about 6 different diagnoses. Everything is male or female. Patient age stretches from 10 all the way to 90. Wow, that's quite a lot. And then we got our hospitals. But right away, I can notice once again something I don't like, which is different hospital naming conventions. Now, this is actually extremely common in the healthcare setting, just because so many departments use different type of names. Some use acronyms. Actually, you got an acronym right there. Some use the provider site, some use the trust. So establishing the naming convention that you're going to use for your data set is extremely important. So you could do what we did before, control and replace, but for here, because a small data set, we'll just use this. If it was a large data set, you definitely want to do control and replace because you could replace thousands and thousands of erroneous data. So I look back up there, all looks clean now, and admission ID all looks generally fine. The next thing I'll go on to highlight and do is just ensure that there is no duplication. So admission ID should really signify a singular admission into those specific hospitals. So the quick way to do that would be just to highlight, use conditional formatting and highlight duplicate values. And we have some duplication. So, how are we going to address this? Well, once again, we've already spoken about this before. There's always multiple ways to solve a problem. I'm not an advocate of always having just one way. I'm teaching you a methodology. Put in the chat and comment anything else that you think is more effective. But this is one way you can do it. You can go into the data tab and utilize remove duplicates. And you can select all of them in this specific case, because actually, let's just verify that that the duplicates are what they think we are. So we'll do a sort by color. We will also sort A to Z so that the duplicate are together. And you can see right here that this is a definite duplicate because admission and discharge are exactly the same. It looks like it's the exact same patient as well. And the same applies for these other duplicates as well. So we're quite confident of removing those duplicates, and select all won't cause us any sort of issue. So we click OK, and it's identified 3 duplicate values and removed it and highlighted that the rest is completely unique. So we seem to be good. So at this stage, then it's all about other sort of preferences you might have in terms of the data cleaning you want to do. For instance, I prefer my ID to always be a numerical value. So if there's any sort of prefix, I like to get rid of those prefixes and make sure my ID is numerical, especially when you're dealing with multiple different data sets. So a way that we could do this is using one of the text functions, because right now it's a general text. And what we're going to do, we're going to use the write, which will return to us a specified number of characters in that text depending from what direction that you're pulling from. So because I said right, it's going to return me the number of text values from that right. So if I go and click on the text and I put 3, then I get those 3 digits. However, this is still a text. 001 is still a text. So I don't like that. I want it to be a numerical value. So we're going to use the value function around the right function in order to just get a digit. And that's the way I like the ID. So we double click there to lower down the relative statements, apply it to all. And you can see from 1 to 100, we got clear numerical values IDs. Don't forget what we did before and really specify the format. And we're going for numbers, no decimal places. Fabulous. Now, at this stage, if there's any other cleaning that you want to do, it's strictly preferential. I can see that the data and the information looks quite good at this stage. But obviously, there's other things you can do. If your numbers are stored as text, you can use the same value function to correct that. You can use if error statements to identify any sort of issues in the column. You can use the rounding feature just to make sure they're nice and whole values. And if you have a lot of data, you might even use Power Query in order to do some of this transformation before it comes into your Excel. But predominantly, we're quite happy with the data cleaning that we've done here and how the data looks. We probably don't need actually an additional 2 ID columns. So what I would do is I would copy that and I would paste that information back in as values so that it's no longer a formula. So it's just a static value. And then that gives us the confidence to get rid of this column. Now, if I was being super strict with myself, it tends to be the convention that you put the ID field into the first field, but we'll leave it as it is for now. So I'm quite happy with the cleansing that we've done. So we can move on to our analysis. So now we're going to look at formulas. So instead of just giving you a list or cheat sheet of all the popular analytical formulas for healthcare, we're going to try and utilize the problem approach and then try to address appropriate solution to that specific problem. But as I keep on reiterating, more than one solution for every single problem. So maybe you got different approaches that you would try. Put them in the comments and provide your methodologies as well for everybody to know. But what's very common within healthcare analytics, especially when you got a breakdown of the age that we have, I think it was 10 all the way to 90, is to break it down by age banding. So sometimes it's a 10-year age banding, a 5-year age banding, and sometimes it's just a breakdown of child and adult. So what we're going to do is we're going to go for the last option we specified and just identify the children we have in this data set compared to the adults. So we can use an if function to do this. And Excel is quite good because with any of the functions that you utilize or the formulas that you utilize, they try to give you the specification of what's expecting. So initially expecting a logical test, followed by a value if it's true, which can actually be an additional condition as well, and a value of false, which can be an additional condition or the result that you're expecting. So in this case, column B is the one that holds the patient age value. So anything above 18 in speech marks, because it's a text result that we want, we're going to say it's an adult. And then in speech mark, we're going to say a child if it's not true. So there we go. For specific age of 10 is specified as a child. So we're going to double click there and you can see the relative statement is being copied down all the way down, specifying it correctly for the different age brackets. So that's a really good start. The next thing we might want to do is identify unique condition situations. So, for instance, a stroke isn't a common thing in the children. So, we might want to put a flag on that to see if a child specifically has a stroke. So, for this formula, we might want to combine 2 different columns values. So, we need to understand if the person's a child, which is held in here, and if the diagnosis is a stroke, which is held in there. So let's do that. So CYP stroke flag, actually, let's put child stroke flag. And we can use an if function again, but this time we want to know if this value is equal to child. And we want to not do that. We want to put this within an AND. So an AND function just allows you to combine multiple conditions. And in order for the value to be true, all of the conditions must be met, or any of the conditions can be met, and it will go towards the value being true. So we got our first condition in there, and then our second condition is if the diagnosis is true. And at this point, we can enter any values. So we can say, yes, it meets the flag, or no flag. So the first condition is a child with asthma, doesn't meet the flag. And if we do that, we can just put the filter on to here now and see we do have a couple that meet the flag. And in this case, we have two. So they specifically are unique conditions that a child has undergone. So that's another way that we can apply conditional formats in this specific scenario. So let's paint another situation. So I actually notice here that the region is actually patient region and not hospital region, simply because if you were to look at some of the regions or one of the hospitals, you can see that you got Manchester Royal, Southeast London, Northwest London, Midlands. So I renamed that to patient region just to make it very specific and clear, and obviously as part of your data cleansing. But one of the key analysis that is done on a regular basis, which is the direction of travel, especially for the NHS and a lot of healthcare services, is bringing treatment closer to home. So what would be really good in this situation is to identify any activity that's happened outside the local region of the patient. So was the patient close to home or not? Now we have here on this second worksheet tab a breakdown of the hospital region by the hospital. So we got this matrix here that identified St. Mary's in the south, Manchester's in the north, Leeds in the north, and then the other three hospitals are in London. So how can we go about solving this problem? Well, one way, let's just remove the filters. And what we're going to do is just hide a couple of columns just so that our comparisons can be visible. So what do we want to see? We want to see the patient region. We want to see the hospital name. And then we're going to have, actually, let's bring the hospital region within this specific data set. How are we going to do that? Well, we can use the famous VLOOKUP, although there's XLOOKUP, which is multi-directional and probably a significant improvement on XLOOKUP. VLOOKUP is still used quite a lot, so we'll just use that for now. So VLOOKUP here gets the specific lookup value first, goes onto your table array. Now, one of the limitations of VLOOKUP is that it expects the lookup value to be in the first available column. So always bear that in mind that if we were to move this over there, that wouldn't work. But XLOOKUP doesn't have that issue. We supply a column index, and that specifically just highlights where is the return value. And then finally, you can provide an exact match or approximate match. So we tend to go for an exact match because we want the exact hospital, but approximate match can work if you're looking for something that matches it to a certain extent. So for this specific example, we can see, so it looked up St. Mary's and it's identified within our table array that it's in the south. Well, let's use a relative statement going down and we get a bunch of errors. So what's happened here? So essentially, it's because we've just told it to use the relative statement, it's going down and changing the cell values as we would expect it to do. However, we don't actually want the cell values to change in the table within the hospital profile. We want it to remain the same because if we go back to the hospital profile, we see that actually our values end at B7 and start at A1. So we just want it to be frozen there. So easy and simple way to do that is just to put a dollar sign, which freezes the row. So the rows won't change. And because you're not changing columns, the columns will naturally won't change. But if you were, you could put a dollar sign in front of the column as well. So let's do that. And we'll do this again. And you see that it's remained the same with the table array, but it's allowed the first lookup value to keep changing and it's provided a value where we expect it to. So that's really good. but that doesn't actually answer the question we were trying to answer, is if patients are receiving their care close to home. So just looking at these two different hospital region and patient region, what we can notice is that actually south can refer to southeast, north can refer to North Yorkshire, London can refer to London. So if we were to find the south value within here, we can say in this instance that they're receiving their care within region. And then if it's not within region, we can say it's outside region. So let's add in another column and we'll call it, what can we call it? In regulatory activity. And we can use for this one the search functionality. So the search, well, you provided the text you wanted to find. So we want to know if it's in the south, and you then provided the text within. So that's the basically the column that you want to look at, or the text that you want to look at and find that specific value in. So you want to find south in that column. And then the start number is just where you want to start, but it's not necessary for this one. So for the first one, it's giving us an error value. Now the search, when it doesn't find something, just gives you an error. But if it found something, it would give you a 1. So let's factor that in and put it within an if condition. So in this specific case, we're going to put it in an if error condition. So that's if error, say out of region. So basically it hasn't found it. It's giving up a value error. So that basically indicates that it's out of region. So that activity occurred out of region. Very good. Or in this specific case, the patient was from out of region going into the hospital, just to make it very prescriptive, the answer. Now, this doesn't completely fulfill our requirements because we get one in out of region, which isn't a nice categorical view of it. So we'll put the whole thing under another if condition. So if this equals 1, then we can say in region. If not, we'll say out of region. So let's look at this. So the first value is given as out of region because the patient is from Northwest. So in an ideal world, the patient would have received their treatment in a hospital that's in the north. So we'll go down our full relative statement and let's just make sure we're getting the right answers. We'll put the filter function back in and we'll just click everything in region. There we go. So London, north, northwest, southeast London. So it's working as intended. So basically all these patients were treated in region. Let's see how much it is. Let's look at a status bar. We see that actually it's 27 admissions were treated in region out of 100, which is because if it's 100, it's beautiful maths, and that's 27%. Awesome. So we've been able to solve quite a few problems using different functions and formulas, which is really good. So we'll just make a quick summary table here. Obviously not ideal to have it within the data set, but we just gonna do a couple of different formulas here. So we want to know what's the average length of stay overall. So we can use the average function. Let's just remove that for a second and unhide the values that we need to see. Let's do an average. So we'll figure out what the average age is. So this is mean average. So we got an average age of 52, average patient age. Let's figure out what our average length of stay is as well. Actually, let's figure out what our total length of stay is. So we can use the sum function for that. So we got 760 length of stay in all of our patient data set and an average of 52 patients. Let me just scroll a little bit to the right as well. Now we can also use some ifs and average ifs, which combine the if functionality with the specific aggregation of a sum or an average and the count as well. So we'll use the count if just to mix it up a little bit. So count ifs is looking for the criteria range, the specific criteria, and then it's going to do the count. So what do we want to specify? Let's count if the patient is from southeast and in region. What about that? Let's do that. So we'll do that. We'll highlight the column. In an ideal world, you just highlight the data set columns. If it was in the table, it would just specify that specific criteria name. And we want to know here if they're from the southeast. So that's the criteria to search for. And we also want to know if they are an adult and if they've been treated within region. So what it'll do, it'll check if the patient row is an adult. It'll check if the patient is within the specific region of Southeast, and it'll check if they were treated in region 5. So what we're going to call this, adult patients treated in region from the South. So that's cool. So that's a really good summary table where we get the average patient age, the total length of stay of our data set, and then the additional bonus of how many patients from the Southeast that were treated in region. So that's a really cool way just to summarize the data and the lesson. Another thing that you can add is also daytime functions, which are super useful. And we'll just do an example one here. So let's say last time in hospital. So the last time in hospital would have been when they were discharged. So you can use equal and you can say today, take away the last time they were hospital discharge day. And you can see that it's thought that the result is a date, but we actually want to know how long it's been. So we're going to put a data format and it's been 415 days since that patient was in hospital from today. Obviously, we know the majority of our data set is 2024 data. So it's going to be a long time since they've been in hospital in this specific data set. So that's cool ways to solve different problems using different functions and formulas. Hopefully you've learned something there, or you've reminded yourself of some of the functionalities and the beauty of utilizing different formulas. Like I said, there's loads of cheat sheets available, so utilize it, but a lot of the thinking and the concept and the problem solving tends to stay the same. Just apply it to different scenarios. So you can actually get some very extensive formulas just combining some of the things. Without a doubt, pivot tables are the engines, the ability that it gives you to summarize, to slice and cut the different data sets in different ways. It makes it such a powerful tool and something that has to be within the capabilities of a good data analyst because it's still so prevalent in the utilization of Excel and a quick way to summarize information. It's even especially bigger data sets as well. It's really good for that. And sometimes you can even do elements of your data cleaning by just looking at pivot tables and identifying certain issues within the data. But it's primarily utilized to summarize it once everything is clean and in a way that you can start to learn from it. So if you go into the Insert tab and you click on the pivot table, I've highlighted everything because it's actually sort of embedded as a common practice to do. But actually, you can just click on anywhere on the pivot table and it'll do exactly the same thing. Like you can see, it's highlighting the whole information, and you can see by this sort of dashed line going around it that it's picked it all up, and that usually tends to appear once it's essentially copied the right information. But it's going to be linked to this specific sheet. So at this point, we can add our pivot table results into new worksheet or existing worksheet, and adding this data to the data model allows you to combine different tables together as well. So for now, we'll just add it to new tables. Here, it gives you a little bit of a preview of when it was going to build your report on here as soon as you start to add fields from the pivot table field list. So here's your field list on the right, and it breaks it down by 4 key options. So the first key option is values that allows you to aggregate the information, whether you're doing addition via sums or average or other mathematical functions. Rows allows you to break the data up into categories. Columns allow you to almost subcategorize it as well. And filters allows you to apply specific fields and filter the information or that you've created within your specific pivot table. So if we just play around with it a little bit, we can put ID into values. Now, it's not probably a good idea to do a sum of the ID because that doesn't really tell you anything, especially in this data set where an ID refers to a specific admission. But if you click on the drop down arrow and click value field settings, you can see that you can change the way the values summarized by a lot of different mathematical functions, but we're going to just use the count, which tells us we got 100 admissions in our specific data set. So if we then add in the age banding, which we utilize to create add-on child, we can see we got 89 children, sorry, 89 adults in this data set and 11 children. If we add in the gender, it lets us filter them by the specific gender here, and you can click M for male. You can see we have 57 overall, and F for female, which we have 43 overall. And then we can do the subcategorization, for instance, the patient region, and we can see that the majority of our patients are coming from the Northwest region. So that's a quick breakdown into that specific combination. And then it's just a case of playing with it in order to learn how the visualizations look. You can actually change some of this in the design, and you can change the color schemes. You can remove the headers in terms of the design of them. The report layout tends to be quite significant. So sometimes when you see different pivot tables and you're like, oh, that doesn't really look like a pivot table, it's just because they changed different aspects of the layout to tabular form to compact form where things are underneath, or tabular form where things are spaced out. And all of that sort of layout changes can sometimes quite dramatically change how a pivot table actually looks within your specific data sheet. If we were just to remove this and add in a data field here, you can see it automatically groups the data. In this case, it's grouped by the specific month and then the specific day. But you can actually ungroup this and get the daily analysis. So if you were doing a daily analysis, you might not want it grouped. But if you want to regroup it, you can select what sort of breakdown you want. So I think in that specific one, we had month and days. And you can see that it's grouped it back to month and days, and then you can collapse and expand the fields as well. So you got sort of different options within your pivot table analysis. One of the commonly used options, let's remove the dates fields and put in, let's create a scenario. So let's try to look at the length of stay by the hospitals. So we'll go up and pick up a hospital. We'll remove patient region, not super interested in that right now. We'll call this admissions just so that it's very clear. And we can see now our length of stay, but we don't want a summary of length of stay. We want average. Now, we know that our averages will be impacted quite significantly by the fact that if we apply a patient age banding, some of the children is not a lot. So we'll remove the admissions just so we can do an analysis of length of stay by day. So we'll imagine that we have a much bigger and larger data set, and we can make such statements like adults are staying longer or children are staying longer in different hospitals. Let's do that. So a feature you can add to it is a slicer. Now, a slicer allows you to essentially apply a filter, but it creates a more interactive element within your dashboard. So we'll add different slicer, we'll add the patient region, we'll add the hospital region, and maybe let's add a diagnosis as well. So I've created here 3 slicers that filter the data again, and then we can start to make really a powerful dashboard in some ways. So we can see how many patients had stroke, what region they were coming from, hospital region, and also what patient region they were in. So you can see quite quickly it can become quite a powerful tool in order to slice the information together. And the timeline one is essentially a slicer, but it allows you to utilize date fields. So it automatically identified 2 of our date fields. So we'll use admission date. And because we only have data for 2 months, we can apply a filter just to look at April, or just to look at May, or to look at both of those specific fields. So that's a really powerful way that you can uh, cut through the data in an interactive format and allow people to create the visualization that they personally want to create. In here as well, you can use calculated field. It's not always used as often, but it allows you to add another field of calculation. So for instance, if we didn't have length of stay, you can add in discharge, take away admission date as a calculated field. and you can see it's literally added in as a measure. It hasn't added into actual data set, but it exists in this measure. And then obviously you can specify how you want that field to look and how you want it to calculate the information, and primarily as well what data format it has to be. In this case, it thinks it's a date, but it should really be a number value. So that's how calculated field works. So we'll remove that for now as well, and just highlight another element or feature that's sometimes utilized. Show details can be really powerful because once you've done some really sophisticated pivot tables, sometimes you just need to see what's underneath that pivot table. So over there, I clicked on Manchester Royal, I clicked on show details, and it gives me the exact breakdown of the data that's contributing to that specific answer. So if I needed to understand if there's any outliers or if there's anything that's truly influencing that information, then that's exactly what I'll do, and just click more detail and opens a new sheet with that specific detail analysis. You can actually double click it as well, and it'll do a similar thing. It's just to highlight that specific feature that tends to be really important, especially when you get like pivot table or a workbook that you personally haven't worked a lot with, and you can see lots of things there. Sometimes you just need to dig into it and reverse engineer it. Clear allows you to clear all the filters and fields, which we won't do for now, and select allows you to select your whole pivot table. You can also change the data source. So if for whatever reason your sheets and the data moves into a different sheet or it's a different location, you can actually change the data source as well. So the final element of our pivot table and charts was utilizing charts. So you can just add in a pivot chart, and the beautiful thing about a pivot chart that is different from a normal chart is that you can change your table around and it will actually change with it. So for instance, if I added hospital region into it, you can see that it's added hospital region as well. So you got the hospital that we're in, the age banding breakdown, and the hospital region it pertains to. So something that would be more interesting would be if they were treated in or out of region. So you can see in St. Mary's, the breakdown of adult and children, all of their patients were treated or came from out of region. But if they were children, but if they were adults, some of them came from in region and out of region. So it lets you make some really clear and powerful statements. And obviously, if you're using a time series analysis, you might want to use a line chart and other charts that are more relevant to date formats. So that is hopefully a good breakdown of the utilization of pivot tables, of pivot charts, and the different things that you can do with it. I think the biggest way to learn is to practice. So literally go onto your workbooks, practice all the elements I mentioned, especially the ones I mentioned in passing, and just see what they can do. And you'll be a master of pivot tables in no time.
Today is a special episode. We compare Dr. Data Insights, a man with over a decade worth of analytical experience, has delivered his fair share of dashboards, digital strategies, reports, and clinically reviewed papers. His opponent none other than the young but famous ChatGPT, the natural language model that keeps on learning and improving every single day. Just to make this even more difficult for him, we will use the Data Analyst GPT. 3 questions, same data set. Point is given for the most complete answer. Who is going to be the judge? Co-pilot. Stay tuned to find out the winner. Question 1. Which diagnosis is most likely to require out-of-region care?
All right, this first question seems a little bit like a warm-up question, but there is layers of nuances that we can add to it to make it a little bit more complex. However, usually when someone's asking you a simple question, they want a simple answer. So we'll try to keep it simple, but apply enough nuance so that we can win, essentially. So we're going to use one of the techniques we discussed with that within our course, not change the data, but use pivot table to answer this specific question. So we're going to just do a frequency analysis. So how many admissions for each diagnosis. So we can use an ID because we know that that's meant to be a unique field. Use the count of the ID. We can apply the diagnosis in our rows to break down this aggregation. Let's just sort it as well by the highest to lowest values. There we go, and we can see stroke is right at the top, but just remember that they said in region activity. So we need that in there, and we're gonna put a filter for outer region, and most definitely we can see that stroke is at the highest. In some cases it would make sense because stroke would naturally be an emergency admission, so you're just likely to go to your closest facility. But let's just reinforce some of this just so that we can add a little bit more detail to our answer. We can put the hospital in the columns field pane, and let's apply a conditional formatting just to quickly visualize. And we can just do the green to white color scale, and we'll visualize how many hospitals had stroke as the highest value. So the darker green indicates a higher number. So we know King's College did, Royal Free, UCLH. The reason it's a little bit less green is because it's doing a comparison on all of the values. So in this case, it's St. Mary's is a little bit lower than the highest of 4. But we can say definitely for 4 of the 6 hospitals within the top 2, and then for at least 3 of the hospitals, it's definitely the highest value. So that just gives us a little bit more context and detail that we can put in our answer that hopefully means that we can take round 1.
Dr. Data answer. The dataset indicates that stroke is the most frequent diagnosis linked to out-of-region care. It is in the top 2 for 4 out of 6 hospitals. This may be due to the urgent nature of stroke cases, where patients are taken to the closest available facility, overriding regional boundaries to prioritize immediate treatment. While this pattern is evident, the dataset is limited in size.
Okay, let's get a little bit of feedback as to why ChatGPT took that first round. So Copilot gives us a little bit of a breakdown table of the different criteria points it was looking at. It noted that we both got the same answers, but let's just go to the verdict. So in ChatGPT, which was answer 1, I tried to create this distinction so it didn't show any AI favoritism. It highlighted that it had a better depth of system thinking, while in my one it highlighted that I brought some real world clinical lens to my answer. So this one's a little bit tough to take because I feel like it's saying that my answer was more realistic, but it's highlighting answer 1 was more actionable and strategic. I guess the question in itself was a little bit vague, so it allowed for more vague strategic answer, which obviously ChatGPT is really good at, but maybe that's just me being a little bit of a sore loser in this first round. But anyway, let's see how we do in question 2.
Question 2. Do repeat admissions correlate with longer average length of stay?
Okay, so let's catch up. Let's try and make sure we win the second round. Now, repeat admissions. Now, just looking at this table, especially I guess one of the key identifiers will be ID, which I'm presuming is admissions ID because the sheet is called hospital admissions, and at the same time, there's nothing to indicate it might be a patient ID. If I just highlight over this column and do a highlight cell values for duplicate values, hide it in light red, you can see that none of the values are highlighted, which indicates there's no duplication in this specific data set. So without enough key identifiers, I am tempted to say that actually there is no repeated admission, or there's not enough information to strictly clarify that there's repeated admissions in this specific data set. Now, that might put me in the losing side, but I'm going to stick to my analytical mindset with this, looking at the specific data set, and I don't see that there's any repeat admissions. Now, this is actually a question that ChatGPT itself posed at the beginning. So it's not my own personal question, but it'll be interesting to see what its interpretation is given this specific data set.
Dr. Data answer. There is not enough key identifiers in this dataset to safely presume that there are repeat admissions. The ID column likely refers to unique individual admissions into a single hospital, of which there is no duplication. In order to identify true repeat admissions, a patient identifier or another combination of reference points would be required.
All right, really happy with that result. It was good to see that Copilot saw my line of thinking regarding this, so it would have been interesting, obviously, if I wasn't right. to understand the reasons why. ChatGPT, which is answer one, and if you want its full answer, I will put in the description so you can see the full answer that ChatGPT gave to each question. But it did highlight that there were some repeated admission and made a comparisons of the longer stays. But it's interesting at this section where it kind of verifies the methodology behind it. And it mentioned with ChatGPT that it was less cautious, potentially extrapolating from non-validated assumptions. So when we go to the overall verdict, you can see that although ChatGPT built on a compelling narrative, it said that my answer had a better methodology and makes a critical point that you can't correlate what you can't define reliably. And that's a powerful truth in healthcare data analysis. Now, I think that this is such a powerful example at ChatGPT making one erroneous assumption and then building a whole narrative around that. Now, in reality, it's built by humans. Humans make lots of mistakes. I make lots of mistakes and make all sorts of assumptions based on those mistakes. But just highlighted that this can happen in AI as well. So if you're not able to reverse engineer it or to understand the context of which a data set is established, you can end up presenting and not understanding why your answer is wrong. So this is such a good example, and I'm really happy I won this round. Let's go on to question 3 and get ourselves a winner.
Question 3. What is the busiest admission day of the week across all hospitals, and how does its average length of stay compare to the quietest day?
Okay, so I'm definitely gonna try and give my best in this one. Just do some cross analysis and everything I can do in order to just make sure we win this one. But this one has a lot of nuances. But what we can use, or at least my thinking with this, is that we can use a combination of formulas, pivot tables, and other things in order to identify the busiest day of the week, but also do some comparison and try to provide an answer that is worthy of the victory. But let's see. So the first thing I'm thinking of here is that we need to identify what the day of the week is. So we're going to need another column. We'll call it day of the week. We can use the formula weekday. Now, if you have any experience in using the weekday function, you'll know you got to provide obviously the serial number or the specific date that you are interested in, but more importantly, you need to provide what the structure is looking for within the week. So notice that the default is looking at Sunday to Saturday. So that means 1 will be Sunday and 7 will be Saturday. What I like to do is more like 1 is Monday and 7 is Saturday. So that puts me under the 11 category. I didn't quite do it at that time. I should have double clicked it, but I'll just put it in there, 11. And you can see that it's told me that this day is Saturday or 6th. You can probably do another formula as well that will give you the specific naming if you wanted to. You know what, let's just do that as well. Day of week, we'll call it a name, and we'll do a switch, which allows us to put one logical expression, give them multiple different results and the value for them. So we'll switch based on this, and if it's 1, then the result should be Monday. If it's 2, then it should be Tuesday. And you get the drift, so I'll just quickly do this, make sure I got everything in the right order so that we're not losing because of an error, which was kind of what happened in the last round, and I don't want it to happen to me, so I'm gonna be extra careful. Okay, so this should just work. Okay, it's noticed some sort of error, so it's implies some sort of correction, but we should quickly see if it is correct. So 6th day of the week represents Saturday. Yeah, I'm happy with that. We extend the relative statement, just double clicking on the plus signs, and you can see 6 Saturday, Wednesday is 3rd day of the week, and yeah, perfect. So we're happy with that. We have what we need there. Now we can identify the most frequency occurrence by using the mode. If you remember, your maths mode will be the most frequent number, so we'll give it that column. and it's saying 5, which represents Friday. So we know that Friday is the busiest day. Now let's put this into a pivot table just to summarize it and try to understand the nuances of that information. So we need our day of the week. We'll use the name to make it easier to understand, put that in the rows. We will use our count. Count has been so important in these questions. That will tell us the frequency of each day. We'll put length of stay as well, because that was part of the question, to understand how that fit in with the context of length of stay. We will do our sort to put it in the right order. All right, fantastic. So we've already identified that Friday was the busiest day, so we can see that there. But interestingly enough, although it had in some cases more than double than the quietest day, Saturday and Sunday, the average length of stay was actually quite similar. And in all honesty, even from the shortest length of stay, which was on Monday 6, it dropped off quite a lot. Now, there's some elements of this that can be due to normal population activity. So sometimes you see a rise in specific days, and depending where in the country you are, in the world you are. So you might have got that initial rise between that Friday activity, but it also can be related to the services. So if we knew the admission types and a little bit more information, we could identify the services that sometimes reduces their offerings or reduces the available services on the weekends. So it's interesting that the drop off on the weekends is actually quite significant compared to a Friday and compared to a Monday, where it seems like everybody's rushing back in. So I think that is a nuance maybe that I can pick up here that maybe ChatGPT won't pick up. We can also look at any sort of diagnosis, or just try to identify, play around with it a little bit, try to identify if anything really is influencing the numbers. We can see that the majority of the diagnosis is appearing on most of the days. So it's not just that Friday you see one type of patient that you're not seeing on the other days. It's just more of them, so to speak. Even in the length of stay perspective, you're not getting all of the short stays or the long stays on that specific day either. So no specific nuances from that perspective. We can highlight as well maybe the age banding, if there's any sort of real discrepancies there. Okay, there's an aspect of the data set, because it's limited, you don't have much values in terms of children, so that's probably not the best representation of it either. So just highlighting those aspects as well just gives us a little bit of a idea of what we might want to include in our answer, in terms of like the complexity of the patients you might be seeing on one day compared to the other day. So it doesn't look like there's a complexity issue, so to speak, just an increase of workload on that specific day. So let's type up our answer, and hopefully we get the win. And I'll make sure I take my time on my answer as well, so I can just submit it and yeah, hopefully get the win.
Friday saw the highest admissions, 23, topping 5 of 6 hospitals, while Saturday was the quietest, 8. This pattern aligns with healthcare trends. Patients often avoid weekend stays, and specialist services may be reduced. Yet Friday's average length of stay, 8 days, is identical to Saturday's, and just 2 hours more than Monday's, falling within an hour of 5 other days. This suggests that while patient volumes vary, case complexity and care duration remain stable, key for planning staffing and skill mix ahead of weekend surges.
All right, so I got the victory. Let's look at a little bit of feedback and understand how I was able to get this one right. So in terms of the actual question and the values that we both provided the same answers. I tried to probably earn some brownie points by providing some decimal points in the average length of stay. It was interesting what the strength and weaknesses said in Copilot. So regarding ChatGPT's answer, it said it was concise and drew plausible cause-effect link between the day and the stay length, but it highlighted that my answer was richer in its context, its data management, robustness, and its ability to recognize subtle system patterns. In the weaknesses, it says that ChatGPT's was a little bit simplified, while mine was a little bit too verbose. And I think that's down to the fact that I really tried to reiterate the points that I was making, and yeah, I probably ended up writing and repeating some of the logical statements I was making, because I just really wanted to win. So overall verdict, I just slightly edged it. So it wasn't like a clear-cut winner, but I just slightly edged it because of my contextual richness and clarity of system insight. So that was a lot of fun. That was a lot of fun. I think all in all, um, ChatGPT made a vital error in the second question, a question that it itself proposed, by not necessarily understanding that data set, and then ultimately made a mistake, and that's what gave me the victory. I think all in all, it was actually quite close, and if it didn't make that mistake, it probably could have gone either way, just depending on the context of how we were qualifying our answers. So it was really, really good exercise. It just reiterated this point that is on all sort of AI tools, is that at the bottom you shall see check for mistakes, or in other ones it says it makes mistakes. So it's just reiterating the point that you still have a measure of accountability as an analyst for the results being produced, and you should at least know how it's generating specific answers as well, although it can do a lot faster than honestly any human can do once it's prompted in the right way. And another little tip, it likes to be prompted, I call it the ego prompt, where you kind of give it credit and get it to become an expert or choose the right GPT, where you tell it, as an expert of so and so, do this. It helps it visualize the answer and create the answer in a way that's more palatable for the audience you're trying to portray that information to. So Google some good ChatGPT prompts or AI prompts and just become well versed in utilizing the right words. But we try to use all of the best practices prompts, so to speak, to try and make it as difficult and as challenging as possible, while making semi-realistic questions based on the data sets that we have. So that was a lot of fun, and hopefully you will catch me in the next episode, and definitely subscribe, like, and all of that thing. So thank you.